Welcome to the MAIT rocketry update for the month of April 2020. Despite the worldly events which have taken place, we managed to get a lot done. Our first research mission feels closer than ever right now, so sit back and enjoy the video. The main goal of the month was to build a flight computer. This is one of the most important components of an experimental launch, as it allows us to retrieve data and deploy the parachute to apogee. As stated in the last update, I'm still learning how to work with C++, so I needed a practice design to help test my programs. I call this contraption Beep because it makes a beep noise. With Beep, I learned how to use state machines to make a program that will safely arm an ejection charge and then begin a countdown when the fire button is pressed. Just to make sure that my MOSFET layout would actually work on an ejection charge, I threw it into the EasyEye65 electronic bay and tested it. It works like a charm. Now that I was comfortable with state machine programming, it was time to move on to the ultimate task of writing a flight computer program. Eventually I managed to make something that works very well. I call it Beep Beep because it beeps more than just once. Beep Beep will detect when the rocket has reached apogee and immediately deploy the parachute. Right now I have the first version of Beep Beep, and you can see the white light is on. That means that we are in our disarmed state. This is where I'm going to be putting it into the rocket, and I can make sure my hand won't get blown off. But basically when I press this button right here, and I'll do this as low as possible, it sets the altitude and it is now armed. Now it's waiting to take off, and when it gets above a certain altitude, that means that it's detected that it's taken off, and we know that it is detected takeoff when the beeper stops beeping. And so I'll go the rest of the way upstairs, and we're just simulating the rocket going up right now. Now when the rocket gets to the top of its flight and it starts going down, we're going to detect that, and that beep means that the MOSFET is firing right now. So right now the ejection charge would be deploying, and for the sake of redundancy, we have a second ejection charge in there in case the first one doesn't work. And so if the rocket's still going down too fast, it'll go again, just like that. So that's basically what Beep Beep does. Meanwhile, we have the altimeter tracking the data on an SD card, and when it gets to the bottom, it'll stop tracking and everything. So there's a lot more in it, but that's basically what it does. Beep Beep Mark I has been finalized on a solderable breadboard. However, there are a lot of mistakes in the assembly that I hope to fix by making a Mark II version. So plan on seeing that in next month's update. I also plan to give Beep Beep its own dedicated video once the design has been refined further. This month, we have not been able to visit our test site due to the current world situation. However, I still wanted to make some progress on the motor testing front, so I decided to redesign our motor test stand. There are a lot of problems with the old test controller. It was slapped together with an Arduino Uno and a shoebox, and the program's lack of redundancy was pretty dangerous. So, I made a new program that saved the data to a separate SD card and has more lights and sounds for the sake of safety. I also slapped together a box to hold all the electronics in and make it look nice. This is the final result. Okay, so here I have the rocket motor test setup, and I'm just going to go to the computer and open up the serial monitor, and when it starts up, it's going to make a little beep noise. There we go. And I'll start a 10-second countdown, and you'll hear the relay flip at the end of it. And now we're getting a whole bunch of data on the serial monitor. When I press down, it gets higher, and there we go. So that is it. This test controller should make it quite a bit safer to test large motors like the iPrototype. You can't just launch a rocket from the ground. Well, you can, but it won't go up. For experimental launches, we need something quite a bit more robust than this SD's Pro Series 2 kit, so I decided to build a launch rail. I first made a CAD model of it, and then I got the parts and started building. most difficult part of the project was finding some way to make the stand resist torque from the rocket. While the design I used was pretty stable, I took it a step further by making the skywire perch. I thought it would be easy to build this thing, however, tightening the fixture without destroying the screw threading in the wood I was using proved to be quite the task. I will redesign this perch in the near future. For now, it is useful for testing the guy wire system. I brought the stand outside and stood it up with the rocket on it. Then I attached the guy wires to the ground and gave them some tension. They work perfectly for keeping the launch stand stable and well supported. Alright, so as you saw in the time lapse, I just assembled this launch pad right here, and it is very stable. These guy wires absorb all of the stress that the rocket's going to send into it. So there we have a launch pad capable of launching high power rockets. Although current events slowed motor testing progress, April turned out to be super productive for MAIT. We built a working flight computer prototype, redesigned the motor testing system, and finally built a launch tower for experimental launches. Next month, we plan to finally test the MAIT iMotor, design and build a radio launch controller, redesign the guy wire perch, and refine the beep beep design. Thanks for watching this monthly update from Mitchell Atmospheric Instrument Transportation.